Let's write a simple Hello World program in Go. Open your favorite code editor and create a file main.go. To run the program, open your terminal, navigate to the folder where main.go is saved, and type. Congratulations! You've just written and run your first Go program. Stay tuned for more Go tutorials and start building your own projects with Go. Let's explore Go's basic data types and how to use them in your programs. In Go, data types are statically typed, meaning every variable must have a type. The common types include numbers, strings, and booleans. Go provides several numeric data types. For integers, we have int for signed integers and uint for unsigned integers. There are also specific sizes like int 8, int 16, int 32, and int 64. For floating point numbers, we use float 32 and float 64. Here A is an integer and B is a floating point number. Strings in Go are a sequence of characters. Here's how you declare a string. Booleans represent true or false values. You'll use them a lot in conditions and loops. Now you know the basics of Go's data types. Start practicing by using these types in your programs, and we'll explore more advanced concepts in the next video. Let's dive into how you can declare variables in Go, a key part of every program. In Go, you declare variables using the var keyword followed by the variable name and its type. You can also declare a variable without immediately assigning a value, and Go will assign a 0 value to it. For simplicity, Go offers shorthand variable declaration using :equals. You don't need to specify the type, Go will infer it. You can also declare multiple variables at once, or even in shorthand. To declare constants, which are immutable values, use the const keyword. Constants cannot be changed once declared. Now you know how to declare variables and constants in Go. Practice these declarations in your programs, and we'll explore more Go features soon. Today we're talking about constants in Go and why you should use them in your programs. In Go, constants are immutable values, which means once a constant is declared, it can't be changed. You use them for values that don't change, like pi or a configuration setting. To declare a constant, you use the const keyword. This creates a constant pi that holds the value 3.14. If you try to change pi, Go will throw an error. Go supports both typed and untyped constants. When you declare a constant without specifying its type, it's untyped and more flexible. Untyped constants can be used in any context where their value makes sense. However, you can also declare a constant with a specific type. Constants are useful in expressions too. For example, you can combine them in calculations. That's how you work with constants in Go. Use them for any value that doesn't change in your program, and you'll write more reliable code. Want cleaner, more concise Go code? Let's talk about type inference and how Go can infer types for you. Type inference means the Go compiler automatically determines the type of a variable based on the value you assign. You don't always have to specify the type explicitly. Instead of using var and specifying a type, you can use the shorthand :equals for Go to infer the type automatically. Go automatically knows message is a string and age is an int based on the values assigned. Type inference is especially useful when you want to write more concise code, or when the type of a value is clear from its context, like in loops or conditionals. Type inference makes code cleaner, but you should still use explicit types when it's not clear what type of variable should be. For instance, avoid using it when working with complex or ambiguous types. Type inference keeps your Go code simple and readable. Give it a try and see how much cleaner your code becomes. Let's explore the operators in Go and how they can help you build better programs. Go provides the basic arithmetic operators for mathematical calculations. You can add, subtract, multiply, divide, and find the remainder using these operators. Comparison operators allow you to compare values. These include equality, inequality, greater than, less than, and more. Logical operators are used to combine multiple conditions. The common operators are and, or, and not. Go also offers assignment operators to perform operations and assign values at the same time. For example, plus equals, minus equals, and so on. These operators are essential for calculations, comparisons, and decision-making in Go. Try them out in your next Go program. Let's dive into basic string manipulation in Go and see how you can work with text efficiently. To concatenate or join strings in Go, simply use the plus operator. You can check the length of a string with the len function. Want a substring? Use Go's slice syntax. Just provide the start and end indices, and Go will give you the substring. Go also provides useful string functions in the strings package. These basic string operations will help you handle text in Go. Try them out in your projects. Let's explore the if-else statements in Go and how you can use them to make decisions in your code. An if statement in Go is simple. Here's how you check if a condition is true. If the condition age greater than or equal to 18 is true, the code inside the block will run. You can extend this with an else block to handle both true and false conditions. To check multiple conditions, use else if. This allows you to handle various scenarios in one block of code. In Go, you can declare and use a variable directly in an if statement. This variable will only be accessible within the if-else block. The variable score is declared within the if block and used throughout the conditions. That's the basics of if-else in Go. Try it out and see how you can use conditional logic to control the flow of your program. Let's dive into switch statements in Go and see how they can simplify your conditional logic. A switch statement allows you to execute different code based on the value of a variable. This checks the value of day and prints the corresponding day of the week. You can also group multiple cases that share the same result. This makes it easy to manage related cases together. By default, switch statements in Go do not fall through to the next case. However, you can use the fall through keyword to enable this behavior. This will print both it's Monday and it's also a weekday when day is 1. You can use conditions in your switch cases for more complex logic. This checks the score and assigns the appropriate grade. Switch statements can make your code cleaner and more organized. Try using them in your Go projects. Let's explore for loops in Go and see how they can help you handle repetitive tasks. A basic for loop in Go has a straightforward syntax. This loop will print the numbers 0 to 4. You can also use the range keyword to iterate over arrays and slices more easily. This prints the index and value of each fruit in the slice. For more complex tasks, you can nest for loops. This will print the multiplication results for numbers 1 through 3. You can create an infinite loop using for without any condition. Use this cautiously. Always ensure you have a way to exit infinite loops. That's a quick look at for loops in Go. Experiment with them in your code to master repetitive tasks. Let's explore functions in Go and see how they help structure and reuse your code. A function is defined using the func keyword. To call this function, just use its name followed by parentheses. Functions can accept parameters and return values. Calling add 2 and 3 returns 5. Go functions can return multiple values, which is quite handy. Calling a b equals swap 1 and 2 gives a as 2 and b as 1. To make your code clear, you can use named return values. This allows you to return values without explicitly using the return keyword for named returns. Functions are key to writing clean and reusable code in Go. Practice creating your own functions. Let's explore how to use multiple return values in Go and why they're beneficial for your code. In Go, you can define functions that return more than one value. This function returns 2 integers representing coordinates. A common use case is returning a result and an error. This function returns the result of the division and an error, if applicable. When calling a function that returns multiple values, you can unpack them easily. This shows how to handle both the result and potential error. You can also define functions with named return values, making it easier to return multiple values without explicitly naming them each time. This function returns the result without specifying it in the return statement. Using multiple return values can make your code cleaner and more efficient. Try implementing them in your functions. Let's dive into variadic functions in Go and see how they allow for flexibility in handling multiple arguments. Variadic functions can take a variable number of arguments. This is useful for functions that need to handle different amounts of data. To define a variadic function, use the ellipsis syntax before the type and the function parameters. This function accepts any number of string arguments. Here's a practical example where we sum a variable number of integers. Calling sum 1, 2, 3 returns 6. You can also use variadic functions with different types, including mixed types, by defining the parameter as an interface. This function can accept any type of argument, making it highly flexible. Variadic functions can greatly simplify your code. Try implementing them in your own projects for more flexibility. Let's explore pointers in Go and understand their importance in memory management. A pointer is a variable that stores the memory address of another variable. This allows you to directly manipulate the value at that address. To declare a pointer, use the asterisk operator. Here's how to initialize a pointer. Here, p is a pointer to x, and ampersand x gets the address of x. You can access the value stored in a pointer using the asterisk operator to dereference it. This prints the value of x by dereferencing the pointer. Passing pointers to functions allows you to modify the original variable. This function increments the value of x directly. Pointers are essential for efficient memory management in Go. Experiment with them in your code for better control. Let's dive into structs in Go and see how they help organize complex data. A struct is a composite data type that groups related fields together. They allow you to create custom data structures. To define a struct, use the type keyword followed by the struct name and its fields. This struct represents a person with a name and an age. You can initialize a struct in several ways. Both methods create a person struct. To access or modify fields in a struct, use the dot notation. This shows how to read and update struct fields. Structs can be passed to functions for further processing. This function modifies the original struct by passing a pointer. Structs are powerful tools for organizing data in Go. Try creating your own structs to manage related information. Let's dive into methods in Go and see how they enhance the functionality of structs. A method is a function that is associated with a specific type, typically a struct. It allows you to operate on the data contained in that struct. To define a method, use the func keyword followed by the receiver. This method greet is associated with the person struct. You can call a method on an instance of a struct like this. This invokes the greet method for the P1 instance. You can use value receivers or pointer receivers. Value receivers work with a copy of the struct, while pointer receivers can modify the original struct. Use pointer receivers when you need to change the struct's data. Here's a complete example demonstrating both methods. This shows how methods can encapsulate behavior related to the struct. Methods are powerful tools for organizing your code. Start using them to enhance the functionality of your structs. Let's dive into interfaces in Go and see how they promote code flexibility and reuse. An interface is a type that specifies a contract for methods. It allows different types to be treated as the same type if they implement the interface. To define an interface, use the type keyword followed by the interface name and its method signatures. This interface requires any implementing type to have a greet method. Now let's implement this interface in a struct. The person struct implements the greeter interface by defining the greet method. You can use interfaces and function parameters to accept any type that implements the interface. This function accepts any greeter, allowing for flexible input. Here's a complete example demonstrating the use of interfaces. This shows how interfaces enable polymorphism, allowing for different types to be treated uniformly. Interfaces are powerful tools in Go for building flexible and reusable code. Start using them to enhance your projects. Let's dive into embedding in Go and see how it enables code reuse and composition. Embedding allows you to include one struct within another, promoting code reuse and a more straightforward way to build complex types. To embed a struct, simply include it as an unnamed field in another struct. In this case, address is embedded within person. You can access fields of the embedded struct directly. This shows how you can access the city field directly from the person struct. Methods from the embedded struct are also promoted, allowing you to call them directly. Here, full address is accessible through the person struct. Here's a complete example demonstrating embedding. This shows how embedding can simplify access to related data. Embedding is a powerful feature in Go that promotes code reuse and cleaner designs. Start using it to enhance your projects. Let's explore arrays in Go and see how they can help you manage collections of data. An array is a fixed-size sequence of elements of the same type. In Go, the size of an array is part of its type. To define an array, specify the type and size. You can also initialize it at the same time. Access an element, use the index. Remember, indexing starts at 0. This changes the second element to blueberry. Looping through an array can be done with a for loop or using range for a more concise syntax. Here's a complete example demonstrating arrays. This outputs each color from the array. Arrays are fundamental for managing fixed collections of data in Go. Start using them in your projects for better data management. Let's dive into slices in Go and discover their flexibility and power in handling collections of data. Slices are dynamic, flexible views into arrays. Unlike arrays, slices can grow and shrink, making them a preferred choice for handling sequences. To define a slice, you can use the make function or shorthand syntax. You can also initialize it directly. Accessing elements in a slice is similar to arrays. Use the index to retrieve or modify values. Appending to a slice is straightforward with the append function. You can also create subslices using slicing syntax. Here's a complete example demonstrating slices in action. This outputs the index and name of each fruit in the slice. Slices are a powerful feature in Go that allow for dynamic and flexible data management. Start using them to enhance your projects. Let's dive into maps in Go and see how they enable efficient storage and retrieval of key value pairs. Maps are unordered collections of key value pairs where each key is unique. They provide efficient lookup, insertion, and deletion. To define a map, use the make function or shorthand syntax. You can also initialize a map with values directly. Accessing elements in a map is straightforward. Use the key to retrieve or modify values. To delete a key value pair, use the delete function. Looping through a map can be done with a for range loop. You can also check if a key exists using the second return value. Here's a complete example demonstrating maps in action. Maps are a versatile data structure in Go that allows for efficient management of key value pairs. Start using them in your projects. Let's dive into the range keyword in Go and see how it simplifies iteration over various data structures. Range is a built-in keyword that allows you to iterate over elements in arrays, slices, maps, and channels with ease. To use range with an array or slice, you can write it like this. If you only need the value, you can omit the index. With maps, range provides both the key and value during iteration. When receiving values from a channel, range continues until the channel is closed. Here's a complete example demonstrating range with different data structures. The range keyword is a powerful tool in Go that simplifies iteration over various data structures. Start using it to enhance your code. Let's dive into error handling in Go and discover how to manage errors effectively in your applications. Error handling is crucial in programming as it allows you to anticipate and respond to issues that may arise during execution. In Go, errors are represented using the built-in error type, which is an interface with a single method, error string. This allows for a standardized way of reporting errors across your code. You can create custom errors using write single quote errors.new write single quote or by defining a custom error type. Define a custom error type for more context. When calling functions that return an error, always check the error before proceeding. Here's a complete example demonstrating error handling in action. Error handling is a key aspect of writing resilient Go applications. Start implementing these practices to improve your code quality. Let's dive into creating custom errors in Go and how they can enhance your error handling strategies. Custom errors provide more context and detail, allowing for better debugging and error management compared to standard errors. You can define a custom error type by creating a struct. This struct can contain any fields that provide useful information about the error. To make your struct a valid error type, implement the error write single quote method. This method returns a formatted string that represents the error. When returning custom errors from functions, you can instantiate your custom error type like this. Here's a complete example demonstrating custom error handling in action. Creating custom errors in Go is a powerful way to improve your error handling. Start implementing them in your applications for better clarity. Let's dive into the defer keyword in Go and discover how it can help with resource management. Defer is a keyword in Go that allows you to schedule a function call to be executed after the surrounding function completes. When you use defer, the function call is not executed immediately. Instead, it is pushed onto a stack and executed in LIFO, last in, first out order when the enclosing function exits. Defer is commonly used for resource cleanup, such as closing files or network connections, and for logging purposes. Here's a complete example showcasing defer in action. The defer keyword is a powerful tool for managing resources and ensuring proper cleanup. Start using it in your Go applications. Let's explore the panic and recover mechanisms in Go for handling unexpected errors gracefully. Panic is a built-in function that stops the normal execution of a Go routine and begins panicking. This is often used for unrecoverable errors. Use panic when you encounter critical errors that your program cannot recover from, such as an out-of-bounds array access or invalid configuration. Recover is a built-in function that allows you to regain control of a Go routine that is panicking. It can only be called within deferred functions. To use recover, wrap it in a deferred function. If a panic occurs, recover will capture it and allow your program to continue. Here's a complete example showcasing how to use panic and recover. Understanding panic and recover is essential for effective error handling in Go. Use them wisely to maintain program stability. Let's explore goroutines in Go and learn how to handle concurrency effectively. Goroutines are lightweight threads managed by the Go runtime, allowing you to run functions concurrently. To create a goroutine, simply prefix a function call with the Go keyword. This will start the function in a new goroutine. Here's a simple example of using goroutines to print numbers concurrently. To synchronize multiple goroutines, use sync wait group. This allows you to wait for all goroutines to complete before proceeding. Here's a complete example demonstrating goroutines and synchronization. Goroutines are a powerful way to achieve concurrency in Go. Start using them to simplify your concurrent programming. Let's explore channels in Go and learn how they facilitate communication between coroutines. Channels are a way for coroutines to communicate with each other and synchronize their execution. To create a channel, use the make function. For example, you can send a value to a channel using the receive operator and receive a value from a channel the same way. Channels can be buffered or unbuffered. Unbuffered channels require both sender and receiver to be ready, while buffered channels allow you to send a limited number of values without a receiver immediately ready. Here's a complete example demonstrating channels in action. Channels are essential for managing communication in concurrent Go programs. Start using them to streamline your coroutine interactions. Let's dive into buffered channels in Go and see how they enhance coroutine communication. Buffered channels allow you to send multiple values before a receiver is ready, improving concurrency and performance. To create a buffered channel, specify the capacity in the make function. You can send values to a buffered channel up to its capacity without needing a receiver to be immediately available. When you receive values from a buffered channel, it operates like an unbuffered channel, blocking if the channel is empty. Here's a complete example demonstrating buffered channels in action. Buffered channels are an effective way to manage communication between coroutines. Start using them to enhance your Go applications. Let's explore the select statement in Go and see how it enhances channel handling. The select statement is used to wait on multiple channel operations, allowing coroutines to handle communication more effectively. The basic structure of a select statement is as follows. You can use select to perform actions based on which channel receives a value first. The default case in a select statement is executed if no other cases are ready, allowing you to handle situations when no channels are available. Here's a complete example demonstrating the select statement in action. The select statement is a key feature for managing multiple channel operations in Go. Start using it to streamline your concurrent programming. Let's dive into mutexes in Go and learn how they help synchronize access to shared resources. A mutex, or mutual exclusion, is a synchronization primitive that protects shared data from being accessed simultaneously by multiple coroutines. To use a mutex, you need to import the sync package. Create a mutex by declaring a variable of type sync.mutex. Use the lock method to acquire the mutex before accessing shared data and the unlock method to release it. Here's a complete example demonstrating mutex usage in a concurrent program. Mutexes are essential for preventing data races in Go programs. Start using them to ensure safe access to shared resources. Let's explore wait groups in Go and learn how they help manage concurrent tasks. A wait group is a synchronization primitive that allows you to wait for a collection of coroutines to finish executing. To use a wait group, import the sync package. Create a wait group by declaring a variable of type sync wait group. Use add to specify how many coroutines to wait for, and call done when a coroutine completes. Here's a complete example demonstrating wait groups in action. Wait groups are essential for managing concurrency in Go. Start using them to ensure your main program waits for all coroutines to finish. Let's dive into working with time in Go and discover how to manipulate time effectively. To work with time, you need to import the time package. Get the current local time using the now function. Format time using the format method, which takes a layout string. Parse a time string into a time object using parse. Use duration to measure time intervals. For example, sleep for a duration. Here's a complete example showcasing various time functions. Working with time is crucial in Go. Explore the time package to harness its full potential. Let's explore timers and tickers in Go and learn how to manage time effectively. A timer allows you to execute a function once after a specified duration. Create a timer using timeAfterFunc, which schedules a function to run after a delay. Timers can also be stopped before they execute using the stop method. A ticker sends signals at regular intervals, allowing you to perform tasks repeatedly. Create a ticker using timeNewTicker, specifying the duration for the ticks. Use a loop to handle tick events and perform actions at each interval. Here's a complete example showcasing both timers and tickers in action. Timers and tickers are powerful tools for managing time in Go. Start using them to enhance your applications. Let's dive into working with JSON in Go and learn how to manipulate data effectively. JSON, or JavaScript Object Notation, is a lightweight data in-array format that's easy to read and write. To work with JSON, you need to import the encoding JSON package. Convert Go data structures to JSON using the JSON Marshal function. Parse JSON data into Go data structures using the JSON unmarshal function. Use struct tags to specify how fields should be encoded or decoded. Here's a complete example showcasing encoding and decoding JSON. Working with JSON is essential for data entering in Go. Start using the encoding JSON package to manage your JSON data. Let's dive into working with files in Go and learn how to manage file operations effectively. To work with files, you need to import the os package. Create a file and write data to it using os, create and write string. Read data from a file using os read file. Always handle errors to ensure your program behaves correctly. Here's a complete example showcasing both writing and reading from a file. Working with files is essential in Go. Start using the os package to manage your file operations. Let's build a simple HTTP server in Go and see how to handle web requests. To create an HTTP server, you need to import the net-HTTP package. Create a simple handler function that responds to HTTP requests. Set up and start the HTTP server using HTTP listen and serve. Handle multiple routes by creating different handler functions. Here's a complete example of an HTTP server with multiple routes. Building an HTTP server in Go is easy and efficient. Start creating your own web applications today.